Hi, my name is Vlad. I'm from Oracle, and I work for Oracle OpenStack for Oracle Linux team. And I want to cover two things. One topic would be running MySQL Cluster database as highly available option for database in OpenStack. And another thing is to cover some problems. If you want to try your own database, what kind of problems you could hit while trying to run it. Okay. If you could know, actually there are two schemas, two ways to run database with HA. Old way is traditional, kind of policy proven and industry proven, is active passive way when you have two servers. One server is running, one is standby, and they share storage device. And we have monitoring software that just checks if connections are okay or not. If they are not, we just reboot active node and pass control to standby. So this one worked quite well for quite some time, but recently we started to demand scalability as well, and we wanted also efficiency, and we wanted clients to talk to all nodes, and nodes would be just scalable to whatever a reasonable size. And currently in OpenStack we have if you look into OpenStack manual, we have actually one solution, one or two. They are very similar. We have MySQL server, patched one with some replication pages inside. And if you check diagram, we have, for example, two controllers trying to talk to database. We have kind of middle layer, HA proxy, keep alive D or whatnot, which just load balance requests to database. And if we hit one of servers after such request, the server makes synchronous replication to all other nodes. So this works so far, but it's very new, and even OpenStack manual sometimes doesn't recommend some things. When I started to work on HA in OpenStack, at Oracle, I try to find out if there are any other options, if we can find better database maybe than just patched MySQL server. I found that there is one. It's called MySQL Cluster, and not to be confused, MySQL Cluster is a product by Oracle. It's in-memory distributed database. It has very long industry history, and it's scalable, fault-tolerant, MySQL compatible, and it's free. For sure, you can pay money for it for some management add-ons at Oracle, but actually to run OpenStack probably it's just enough. And I asked myself and my colleagues if we can run MySQL Cluster with OpenStack, and nobody replied. They just say, well, just try it out. And I started to investigate this very nice product. Here I just show you a small architecture slide. MySQL Cluster actually has as a core NDB cluster engine. This is called NDB for short, or network database. And we have three types of nodes, so-called NDB or data nodes, where we store data. We have API nodes, or simply saying it's MySQL server with some modifications that can understand anything else, not only InnoDB or MyISAM. And we have a couple of management nodes. They don't need to scale at all. It's just probably one is enough, actually, to run everything, but two is just to be sure if one fails. And NDB cluster actually has different APIs. You don't need to use MySQL even to talk to NDB nodes. You can use C++ and whatnot. But for our purpose, we use APIs which talk SQL. Okay, so how it works usually? We have HA proxy with keep alive D. It's load balancing with virtual IP. So OpenStack can be configured, or any clients could be configured with just one virtual IP, and HA proxy makes sure request goes to necessary API node. And API node can be collocated with controller nodes as well, or can be separate. It can be scaled to up to 255 nodes. If we have that many controllers, that's zero in theory. And then what API node does, NDB cluster stores data rather very clever way. All tables have indexes, and with this index, we can shard data. So we split data into pieces and put into different groups of servers with necessary replication factor. So it's not replication to all servers, it's just to two, for example, in this case. If you come from storage area, you could tell that this is just rate 1 plus 0, and you would be right. And management nodes usually necessary to bootstrap a whole cluster. For example, they have configuration IP addresses for all nodes, so they know each other. And other nodes just call management and ask for configuration. So that's easy. If you try to run anything but InnoDB with OpenStack, you'll find several problems I had to actually solve myself. I have found that current OpenStack sources in different projects, they are very InnoDB centric, and you can't just do easily any other database. So first thing when I tried to run it, I have found that all migration scripts of different projects in OpenStack, they have hard-coded InnoDB string as default engine. This was awful, and fast and furious way to work around this problem with just running set through all sources of, for example, Cinder or Keystone, and replace it. And yeah, clever way would be just to leave default engine setting to servers, or to put into some configuration file. Definitely not in Python code. Another thing I have found quite difficult to change, but it's still it can be solved. That those scripts, migration scripts, they use try to use some knowledge about InnoDB. And for example, naming conventions for keys, indices. If you don't explicitly name your key, foreign key in InnoDB or any other engine, they'll give some strange name their way. For example, in InnoDB, there will be something like metadef properties, whatever, /1. Key, and in NDB class it would be foreign key 1, 2, 3, 4, 5, 6, and whatnot. And actually, this problem arises when we have several scripts for migration. Usually, there are dozens of them. One script does addition of columns, modifications, adding indices, foreign keys. And maybe a few scripts later, another script decides you don't need foreign key, let's delete it. This becomes a problem because you didn't name your key. And I have found too that, well, the easiest way, probably also is kind of workaround, is just to explicitly name such indices by name and then delete them. But actually in SQL Alchemy library, you can use naming conventions, and you could just tell that your keys would have some uniform names. So, and the third thing I have found not nice about current OpenStack source is that people tend to use this large strings by default for whatever they find string or text information. For example, for status fields or for hostname fields, they just use varchar 255. They don't think just whether it's too big or not. And since NDB is an in-memory database, it has stricter limits for row-wide sizes. For example, in NDB, it's just 14,000. If you just sum sizes of all columns, it should be 14,000 bytes, no more. And in MySQL server, just normal InnoDB engine, it's 3 times bigger. Okay, all that said, if you do such changes, you can integrate your engine, maybe not cluster, but something else. But I tried and it worked really great. I think OpenStack can really benefit from this engine. Yeah, thank you very much.